Question 37. Joan prepared two identical glass containers, funnels and stoppers in setup P and setup Q as shown below. So she poured 20 ml of water into each funnels in both setups and measured how much water entered each container. And she observed that the water could flow down easily in setup Q, but it stopped flowing down in setup P after 10 minutes. So what happened is Joan recorded the results in the table shown below. So there are two identical setups, but actually there is a difference between P and Q. And you notice that in setup Q, there is actually a hole at the side. Okay, so let's see what happened. So setup P, after a while, there was only 5 ml of water inside, but setup Q, all the water that was poured into the funnel is able to enter the glass container. Okay, so the first question is, what is preventing all the water from what is preventing all the water from flowing into setup P? So what is there in setup P and Q at first? So although it might look empty, but remember there is air present inside. So we're going to write air. There's air present inside. So over here in setup Q, the hole, it will actually allow a hole for the air to escape. But in setup P, there is no hole at all, so there will be air containing inside the glass container. Alright, so what is preventing all the water from flowing into setup P? It is actually the presence of air in the glass container. Alright, that is preventing all the water from flowing into setup P. Okay, B, based on the table above, only 5 ml of water could enter P. So why do you think this was so? So yes, there's air, but it's not that it's completely blocking the water from entering. There's still 5 ml of water that can enter. So why do you think this is so? So you're supposed to explain why. So let's recall the properties of air. Air takes the shape of the container. Air does not have a definite volume, so therefore it can be compressed. So let's look over here. What property is it that we're observing? Because 5 ml of water can enter, is actually stating that because air can be compressed. Okay, so the answer is actually the air in the container occupies space. Okay, hence water cannot flow into the container easily. However, air can be compressed. Allowing some water to enter the glass container. Alright. So this is the answer. Air occupies space, so therefore the water is not able to flow through it easily compared to setup Q. However, because air can be compressed, some water can still enter the setup P in the glass container. Okay, so how does the hole in the stopper enables the water to flow down the setup Q? So the reason is because the hole is there to allow the air to escape. Alright, the hole in Q allows the air in the container to escape. So this allows water to enter the container and occupy the space. Okay, or you can say that because there's hole, it allows air to escape, hence allowing water to flow down easily into the container, or making space for water to flow into the container. Alright, so any one of this is accepted. Alright, question 38. Question 38. During a science experiment, Jamie dropped an iron ring into the plastic tank filled with water as shown in the diagram below. So she wanted to remove the iron ring using a magnet. So she wants to use a magnet, only one magnet. Alright, so describe how she can do so without getting the magnet wet or changing the setup. Okay, so she's not supposed to put her hand in, or she's not supposed to put the magnet into the water. She has to just use the magnet to take the ring out without getting the magnet wet. Okay, and you're not allowed to change the setup as well. So what you can do is to place the magnet by the side of this plastic container, because plastic is a non-magnetic material, so therefore it can attract the iron ring. So once it's attracted to the iron ring, it can then move up and bring the attracted iron ring to the opening. So I'm going to show you the answers now. So she can place the magnet or the bar near the iron ring or beside the plastic tank, and the magnet will attract the iron ring, and then she can bring the attracted iron ring to the opening of the container and remove it. Okay? Alright, next, Jamie attended a birthday party and wanted to perform a magic trick. She tried to attract some copper coins with a strong magnet, but she was unable to do so. So what she's using here is copper coins and a magnet. Okay, but she realized that it is not able to attract the copper coins up. So why is this so? So the reason is because of copper. Copper is actually a non-magnetic material. So because it's not magnetic, it's not able to be attracted to the magnet. So copper is a non-magnetic material. Alright, question 39. Mary made an electromagnet by coiling an iron nail with wire and connected it to the ends of the battery as shown below. So Mary tested the magnetic strength of the electromagnet by counting the number of steel paper clips that the iron nail could attract. She repeated the experiment by increasing the number of coils around the magnet and recorded her observations in the table below. So she repeated the experiment a few times. After each time she increased the number of coils, she placed some paper clips by the side of the iron nail and see how many paper clips are attracted to it. So this is the result. So here you're supposed to state the relationship between the number of coils around the iron nail as well as the number of paper clips attracted by the electromagnet. So if you see here, as the number of coils increases, the number of paper clips attracted to the magnet also increases. So that is the relationship of your coils and your paper clips. Alright, so the greater the number of coils around the nail, the greater the number of paper clips. Or you can say the fewer the number of coils, the lesser the number of paper clips. Alright? Next, besides increasing the number of coils around the magnets, name another way Mary could increase the magnetic strength of the electromagnet. So how is she able to increase the strength and make it attract more steel paper clips without increasing the number of coils? Okay, so there are two methods. One is to use more batteries, or the second one is to use stronger batteries. Okay, see what will happen to both the iron nail and the steel paper clips if the batteries were removed from the setup. So if you were to remove the batteries, what will happen to the iron nail and the paper clips? So without the batteries, the iron nail is not an electromagnet and is not a magnet. So because of that, it's not able to attract the steel paper clips. And this is because the iron nail will become demagnetize, or the iron nail will not become magnetized. Okay, so this is the answer for C. So you observe that the iron nail will not be magnetized. Okay, and because of that, your paper clips will not be attracted to the iron nail. Okay. Or you can say that the iron nail will become demagnetized if the batteries are removed, and therefore it will no longer attract the steel paper clips. Alright, question 40. Question 40. Fiona placed 4 similar bread slices in 4 identical steel boxes as shown in the diagram below. So she placed P and Q in the fridge and R and S in the garden. Okay, so X, substance X is here to absorb moisture from the surrounding. So X is there to remove moisture. So in box P, Q, R and X, which mole appear first? So we must go back to recall what are the conditions necessary to help mole grow. So in order for mole to grow, there must be 1, moisture, 2, air, and last of all 3, warmth. Okay, so these are the 3 conditions needed for mole to grow. Okay, so which box is the one that has all 3 conditions? So if it's in a fridge, will it be warm? No, it will not be warm. So P and Q is actually going to take a longer time. So let's look at R and S. R and S, R has water, which is moisture, but S actually has X, which is your substance that removes moisture. So without moisture, S, although it's in the garden, it has warmth, it has air, but it's not able to grow. So the box in which your mole will grow first is actually box R. So the reason is because in box R, it has the conditions, which is has air, warmth, and moisture for the mole to grow. Okay, so it must have these 3 things: air, warmth, and moisture for mole to grow. So these 3 are the important things.